Welcome, ladies and gentlemen, to the second tutorial. This tutorial is about the grid dimensions. So let me drop first a grid. Oh, let me zoom out a bit. A grid. And what we're going to do in this tutorial is to auto dimension this grid. So we can do it like the old way, like go to annotate, align, and we can click. There's a dimension, but but Dynamo can do this for us. So let me delete this grid and let's go to Dynamo. Dynamo. I already opened a new file. I got some packages, but for this tutorial we don't need any package. We just use the standard nodes from Dynamo. Alright, so the first thing what we need is dimension. And we can see here a node by element. That node is what we need. The output is a dimension and the input is a view, a reference element, a line, a suffix and a prefix. The view is corresponding to the view in our Revit files. So if we go to view all, we got a structural plan view, a floor plan view, a ceiling plan view. That's in my case. The reference element is the element that you want to put a dimension on. In our example, we are going to dimension the grid system. So here the input is our grids. We can input a line. This is not necessary actually. A line, suffix and prefix are not necessary for this node to work. The line is, you can put in a line, and if you draw a line, it will put the dimension on the line. And the suffix and the prefix is something from Revit. If we go back to Revit, if we draw our dimension and we double click on the number, we can see here our prefix and our suffix. We can fill in some text in it. So let's say test and let's say millimeters. Apply. And you can see the text in the front and the text on the end. That is what the prefix and the suffix does to the dimension. So let's delete the dimension and let's go back to Dynamo. So the first thing for our input is a view. So let me type in views in the search entry, views. And this node allows us to select a view. If I can see the description, yes. All views available in the current document. So like I mentioned before, I got 3 views. So let's select one and connect it to the view. The second thing what the dimension by element needs is a reference element. So we're gonna get our grid system in Dynamo. First thing is category, because a grid system is a category, the grids. So let's select category and open the drop down, search for grid. As you can see, grids. The second thing what we need is all elements of category. Let me scroll down a bit. All elements of category. This allows us to get all the elements of our category. So we get 2 grids. If we put in a watch node, we can see 2 grids. Alright, so let's delete the watch. Before I'm gonna connect the element to the reference elements, we're gonna switch from automatic to manual, because Revit and Dynamo crashes if you leave it on automatic. So let's connect it up right now and let's run the script. Run complete. Let's go back to our Revit, and we cannot see here in this view, of course. Let me see which view I placed it in the structural plan. Alright, we can see here our first dimension. It placed it in the middle of our grids of our element. That's the default value of the, let me go back to the node, of the dimensions by element. So what we do now is we're gonna extend our grid system. We're gonna draw 2 more grids. Grid, gonna go in the X direction, like so, and like so. And now we want a dimension from 4 to 3, or from 3 to 4. So let's go back to Dynamo. Let me grab it. And if we run it, gives us an error message. This is because the reference are the highlighted dimensions are no longer parallel. Sorry guys. That's because we got one in the X direction and one in the Y direction, and Dynamo and Revit don't like it if you put them with the same script. Put it in. So let's go back. So as you can see, there's no dimension in the Y direction, so we're gonna fix it. So let's go back to Dynamo. So what we need to do is to find out the direction of our grids. So let me place it over here, like so. So what we're gonna do is we need our geometry. So let's search for grids. Yes, that's it. Curve. Alright, this node allows us to get the curve of a grid system. So if we put the element into the grid curve and we say run, you can see, there it is. Let me zoom out and turn it a bit. This is our current grid system. It imported from Revit to Dynamo. So now we have our curve, and if I watch it, let's use a watch node actually, that's better. Let's run the script. Doesn't really matter, I see. Alright, but what we need is the direction. We got direction vectors, and we got a direction in the X, and we got here a direction in the Y. So we need to get those directions. So we go to our search and search for get direction. The direction of the curve, yes. The input is a line, the output is our vector or our direction. As you can see here, let me do a little bit. Yes, direction is vector. Alright, so let's drop the curve in. Let's run the script. And as you can see, we got our vector x 0, 0, and vector x 11 meters and minus 11 meters. Alright, what we need to do next is to make a filter of our X direction grids and our Y direction grids. So we have get a watch node, watch, so we can see it. Elements. We have 4 grids, and 2 of them are in the X direction and 2 of them are in the Y direction. So we need to filter that. Let me move this a little bit so we have some space here, like so. So how are we gonna filter this? Well, the easiest way to filter it is to get the X or the Y vector. So if we say here get X vector, get the X component of the vector, yes. If we put our vector inside the input vector of our X and we run it, we get only our X vectors. You can see here a negative number of minus 11. That's really weird, but actually it's 0. So what we can do with this data is we can use equals not. Because the data what we want is not 0. As you can see here, this is 0, this is 0, this one is 0, and this one as well. But we want the opposite, we want the numbers. So we pop it in, and we need a number to equalize it, or not equalize it actually, a number. And the number is 0, yes, that's true. So if we connect it up, and if we run the script, you can see here, true, 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 false. Why true, 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 false? 0, 0, and 0. Oh, I did use the wrong. X greater or equals. That's not what we need. We need X doesn't equal Y. Sorry. I would say that something is wrong. Let's connect it and run. And as you can see, false, false, true, true. That's what we need. That's our prediction. Alright. Now we have the bool. We can filter our main list, our element list. So we need filter by bool. Yes. Our mask is our output, or false, false, true, and true. And our list is our are our elements. So let's connect that. If we run it, it did a test, and if we use a watch node, you can see which elements were true. So if we run it, you can see grid 2762 and grid 2821. Alright, if we connect it up to our reference element, and if we say run, we will see in Revit it made another one. It made this dimension. Let me, sorry guys, delete both of them. So we can see it only makes one right now. If we run it, go back, one dimension. But the other one, it's lost. Let's get it back. So we're getting it back by putting the output and the input in a list. So let's create a list. I explain to you guys why. Because the input are all the x directions and the output are all the y directions. So if we connect them up into a list, you can see a run. We can see we get list 0 with our x directions and list 1 with our y directions. And if we go back to Revit, you can see it made two dimensions. Let me delete this one because there was already one. Run it again. Let's see the output, 2 dimensions, and you can see 2 dimensions. This is actually the basic plan for dimensions. We can extend this. In this video we are going to create an offset with a line, so we don't get it in the middle of our grid. Alright, let's go back to Dynamo to make this extend to, let's say, here or the above. It's a little tricky, we need some formulas for that. So let's go back, and as you can see, let me just extend this a little bit. This is making our direction, and now we need to make an offset, or we need to create a line. That's what we're gonna do. Let me delete this watch node first, connect it up. So we got our x direction. Let's go to that first. What we need is a geometry from our x direction. So we need the same node again. So let me copy this. And the in was our x. Let's paste it. Create another curve. And now we need our... These curves are only the x direction. If I click it, I think I can show you a curve. Yes, start point. And where's the other one actually? Start point, oh yeah, there it is. What we need to do next is to create a line from here to here, or from here to here. So we can draw a line over here, so we can put our dimension here on the line. So we need our start and end point. Start point. Start point. Get the start point along the curve. Yes. The curve, we put it in, and the output should be our point. Let me run it. Yes, this is our start point, and this is another start point. As you can see, we got a start point here, and we got a start point here. This is because I drew the grid from here, from here to here, and the other grid, I drew it from here to here. So that's why our start points aren't aligned. So we're gonna fix it by getting our endpoint. Doing the same thing as our start point. We run it. Let's see. Yep. As you can see, it created now 4 points. So now we need a filter to filter our start and our end points, so we can create a line between this point and this point. Alright, what we need to do is to get our x coordinates, because we're creating a line in the y direction, so the y needs to be equal on each other. So let's grab x, get x, point, sorry, get the x component of a point, yes. Let's connect it, and the other one as well, from our endpoints. Now we got both X points. Let me run it first. Let's see. Yes. Let's see it here as well. Yes. The next thing what we need to do is we need to filter it. So we need to compare this list to this list, and we need to compare this whole list to just a single item, every item in this whole list. So we're gonna make this with first count. We need to know how many numbers we have in a first list. So connect to list. And second, we need a repeat. A repeat. Oh, it's my keyboard. Repeat. The repeat node allows us to duplicate lists in different lists. Let me just show you. It's a little bit hard to explain actually. Like so. We got list 0 with our items, and we got list 1 with the same items. And now we can use an equal x to y. And we put on this list in the y, this one in the x. And if we run the script, you will see false, true, true, false. Now we can make our filter. So let me put it down a little bit, and we need a filter by bool. Yes. Where is it? What the? Ah, here it is. So we put our mask in the list filter by bool, and we put in our start and end points. So let's create a list from our start and end points. This one and this. Let's put it here. Let's just clean it a little bit up, because like so. You can see. Let me run. We have 4 items here as well. We got our 2 start points and our 2 end points. Now we can connect it to our filter, and the input, or the what matches, is our start point and our end point for a line. So let's make a line by start and end point. These are all our start points, and these are all our end points. So let's can we connect it? No, we can't connect it directly in it, because it doesn't know what's the start point and what's the end point. We need to separate this 0 and this 0. So we're going to do that with first item, and we need last item. This allows us to get the first list and the last list if it is in a list. You can see it. Let me connect this both and run the script. As you can see, the last one, then 8 with a 7. Oh, let me turn around this. Sorry. the last one with the 766. That's this one, and in the top list we got our first item. If you use multiple grids, you can still use this method, because this is a list in a list. So the first item is list 0. So all of our start points will display in the second list. So this is a list on its own, and this as well. So let's connect it up to our start point and our end point. And let's run the script. And as you can see, it's a line exactly where we want it. And if we put the line in our dimension by element, connect it up, and then run the script, go back to Revit, we can see it draw our dimension on the edge of our grid. So now we want to draw another line, another dimension on the edge of these 2 grids. And that's not that hard actually. Let's go back. We need to copy the whole thing. We need to copy all those nodes. Sorry. Let me copy it like so. This is our X, this is our Y. And the only thing that we need to change here is we don't need the in, but the out in our grid by curve. And we need to change the point X, both of them, to point Y. So get point Y, Y, and again. Let's change it. So the point, the curve start point in point, and the exit in the count and in the X. Delete this one, and the Y direction of the Y point from the end point needs to be in item, like so. Delete the X. Only thing what we need to do is create another list. We have a list here. This list contains 4 of our grids. We only drew the dimension for those 2 grids, and now we're going to draw it for those 2. So what we need to do is to disconnect the line, and we need to create a list. So list. We're going to extend it with 1. We put our X line in it, or a Y line actually, and our X line. This one, put it in item 1, and if we run it, you can see it draw the other line as well. We have now 2 lines, line 1 and line 2. If we connect that up in our dimension by element in the line, we have list 1 with our elements, line 1, and we got list 2 and line 2. So if we run it right now, go back to our Revit, you will see through here a dimension and a draw here a dimension. Okay, I'll save it. So this is the basics of our dimensions for a grid system. We can expand it with multiple grids. Let me just show you. Let me say copy. Oh, there's something wrong. Copy this. Sorry guys. Let me just copy it and then run the Dynamo script again. So let's run. And as you can see, it made another line, and here's the dimension. So this can be go endless big. The next thing what we're gonna do is to open a script what we made by Your Ydea. Let me delete. No, not delete. Let me save this first, and let's save our Dynamo script for you guys so you can download it. Save and grid dimensions. Save. Yes. All right. All right. So let's close this file. Close. Let's go back to Revit and delete all of this. Delete. First, we need a grid. So back to Dynamo. Dynamo is here. I'll open first our grids. This grid system we designed last week. Grid design. Open a file. Let's see. 6 meters. Let's run it. Makes our grid system a little bit. Oh, all right, it's done. As you can see in the background, this is from the previous tutorial how to make a grid system with Dynamo. I use it right now so I can make a fast grid system. Let me close this. If we go back to Dynamo, you can see this is our grid system. Alright, let's open the script from Your Ydea. This is our script, grid dimensions, open. We used the same method as you guys did, as we did in the last scene, but we changed some stuff in it. Let me it's loaded. Let me show you. Our input is still a view, but we changed some other inputs. We can choose, do we want our dimensions on the left side of the grids or on the right side? And do we want it on the bottom or on the top of our grid system? We can also use our input and offset for our grids. So just let's run the script. And let's wait a sec. There it is. You can see it in the background. Let's go to Revit. You can see it dimensioned the whole grid system at once. If we go back to Revit, or sorry, Dynamo, if we change our offset to, let's say, 0.5 meter, and we run it, you can see our lines plop up 0.5 meter outside of the grid system. So let me show you in Revit. Like you see, it's 0.5 meter outside. If we want to go inside, we just say minus 0.5 meter. And we run the script, and it's on the inside of our grids. Let's see it in Revit. You can now see it's perfectly aligned inside our grid system. You can measure it. Wow, like this, 0.5 meter. Alright, that's it for today. I hope you enjoyed this video. If you enjoyed it, please consider to like the video. And I'll see you guys next week.